Hey guys, this is a quick video on Monte Carlo simulation. In this problem, we will lead into the simulation requirement, which is the last segment of the problem. However, we will go through a couple of items that we need to solve before we get there. You can follow the solution for those A and B items, or you can just ignore them and just use the information as part of the giving input to solve the Monte Carlo simulation. So anyway, we'll go over through all of them. A company is trying to predict the long-term or the long-run market share of a new men's deodorant. Based on initial marketing studies, they believe that 35% of new purchasers in this market will ultimately try this brand. They believe that customers will purchase their brand at about 60% of the time in the future. Preliminary data also suggests that the brand will attract heavier than average buyers, such as those who exercise frequently and participate in sports, and they will purchase about 20% more than the average buyer. In A, we need to calculate the long-run market share that the company can anticipate based on these assumptions. And in B, we need to develop a general model for predicting long-run market share. Once we do that, suppose that the estimate of the percentage of new purchasers who will ultimately try the brand is uncertain and assumed to be normally distributed with a mean of 35% and a standard deviation of 4%. Use the norm inverse function in Excel and a one-way data table to conduct Monte Carlo simulation with 25 trials to find the distribution of the long-run market share. Notice in this question they are asking for a number of trials, but if you do this kind of analysis in your work, you can determine the number of trials that you like to use. Now, this is a solution template that allow us maybe to go over guide us into the solution, the Monte Carlo simulation. So in A, the percent of customers buying or trying the brand are 35% of those, or these 60% will buy in the future. Thus, 35% times 60% will give us a 21% of the market will purchase the product in the long run. In addition, if the customer base will buy 20% more than the average buyer, then the long run market share will be increased by 20%, which we multiply by 1.2, and that will give us about 25.2%. If we make some assumptions for B, like let T proportion of customers trying the brand, or proportion of customers who purchase, and B, the buyer index, which is set at 1 for the average. Therefore, anything above average, like 20%, will be 1.2, and so on. Therefore, the model that is being requested is T times R times B, which T is 35%, R is 60%, producing 21% repeat purchase share. Buyer index is 1.2 for those who buy 20% more, and the long run market share is 25.2%. Now, this is a template as far as how you prep for the Monte Carlo simulation. You make a little table with the given data, like the mean and standard deviation. This is 35%, the values given to us in the problem. The standard deviation is 4% given to us in the problem. We prep this side, which is TRB, the elements of the model. In this cell, you will put the formula that they have asked us to, which is the norm inverse, and we will use 35% and 4% to fill in the data. 40%, you will be asking why not 60%? Because 60% will buy in the future, which means 40% are currently buying. Therefore, we enter 40%. 1.2 is the market index for the average, or the buyer index. It's at 1.2. You can use 115 if you wanted to. In this case, we are using 1.2. And this cell is the model outcome, T times R times B. Once you put your cell here, your formula, the norm inverse formula then, or function, then you will be able to multiply these three. And this is the table that you will prepare for the production of simulated data. This is where you put your T, C24, which you will put here. Long run share is C28, which is the outcome of the model multiplication. And these are the 25 trials. And once you run the simulation, it will fill this table for you. The way to run the simulation is to highlight the table, like highlight everything, all 25 trials with the formulas here without the headings or the column titles. And then you will go to data tab and the what if analysis, go to table, data table. And then you will get that small dialog box, which you will leave the raw input cell as empty, and then in the column you will just choose any empty cell, and then you will click OK, and you will get the results. So just to demonstrate that for you, go under the data table, and then you will go to what if, and you go to data table here. You will leave the raw cell empty, and you will go to the column and you will just pick any one and hit OK. We will not do that here, but we will look into the solution because these data here are zeros. So if we run it, it will give us all zeros. And therefore, we will go here where everything is. This is the final solution, but we can redo it to check on the steps. So this is this is the simulated data that Excel produced for us. This is the 35%, the 4%, this is the T inverse, and of course the data numbers change because the table position has changed. But this is the T, the R, and the B, and this is the model outcome, which the model outcome is put here. The T is put here, and we will do highlight everything, all the trials, all 25 trials. We highlight all of this. And then we go to data, what if analysis, data table, leave the row blank and put the cursor here in the column. Just select any blank one, hit OK, and therefore you got simulated data. So there is the simulation is working, and this is the simulated data, and you can track those or graph them to learn how what is the simulated anticipated trend of the market share. Thank you.